This is 1.3, Evaluating Limits Analytically, first day. So last time we talked about evaluating limits using a graph and using a table, and today we're going to talk about evaluating them analytically. So our first three rules that we're going to talk about are just basic rules. So the first one, the limit as x approaches c of b equals b, basically saying that the limit, no matter what you're approaching, of a constant is that constant. So over here we have this example, limit as x approaches 2 of 3. Well, it's a constant function, so that's just 3. The second one is if we have just like a linear equation, basic y equals x, the limit as x approaches c of x is c. Okay, so whatever you're approaching, that becomes your limit. So for this example, the limit as x approaches negative 4 of x is just negative 4. And then the last basic limit rule is the limit as x approaches c of x to the n equals c to the n. So for our example here, the limit of as x approaches 2 of x squared is going to be 2 squared, which is just 4. So really, really basic rules we have there. So we have some other properties of limits. So we have 6 of them here. The sum rule and difference rule, basically, you can either add the functions together or you can just add their limits together at the end. Same thing with difference. Same thing with product rule. Constant multiple rule, if you have a constant times a function, the limit is just that constant times the limit of the function. The quotient rule, take the limit of the top divided by the limit of the bottom, granted that the limit of the bottom is not equal to 0. And the power rule, if you have a function raised to a power, just take the limit of the function raised to the power. So let's do an example here. So we're going to use all of our rules and split them up. Okay, so what we're going to do, I'm going to split this up. First of all, I'm going to use the sum rule since we have this plus here. So I'm going to split it up to be the limit as x approaches 2 of 4x squared plus the limit as x approaches 2 of 3. All right, this first limit, okay, we can split that one up even more. So I'm going to use the constant rule. Fill in those 2's there. We're going to use that constant rule. So this 4, I'm going to take and put out front. So 4 times the limit as x approaches 2 of x squared plus the limit as x approaches 2 of 3. All right, using our basic rules that we talked about, this limit as x approaches, or 2 of x squared, remember we just plug in the 2, that's 2 squared, which is 4, so we have 4 times 4, plus the limit as x approaches 2 of 3, that's our constant rule, so that is just 3. 4 times 4 is 16, plus 3 gives us 19. So that whole thing, that original limit that we started with, gives us 19. So this is really handy if you don't have a graphing calculator or any type of calculator handy with you right at the moment. All right, more rules for limits. So polynomial and rational functions. Basically, what you got to do is you just have to plug in that c value for both of them. Rational functions, make sure that the denominator doesn't go to 0. If it does, we'll talk about that later. But basically, we are just plugging in our numbers. So let's look here. The limit as x approaches negative 3 of 4x plus 2. All we're going to do is plug in negative 3 for x and evaluate. So 4 times negative 3 is negative 12 plus 2 is negative 10. So our limit is negative 10. For this next one, we're going to plug in our 2 2 squared is 4 times 2 is 8. 3 times 2 is 6. 2 cubed is 8. Simplifying, 8 minus 6 is 2, plus 1 is 3. 8 plus 4 is 12. If we simplify that fraction, we get 1/4. Okay. The nice thing about these rules is that it's a lot easier than up here when we just did a bunch of work to split them up. Now we can just substitute in and plug in our number and solve. And the last thing we're going to talk about today is just a couple more limits. So radical functions, when you have square roots, cube roots, it works to just plug in that c value, but there is one little thing we need to pay attention to here. So it works for all c if n is odd. So if we have a cube root or a fifth root or a seventh root, etc., it's going to work no matter what. But when you have n as even, okay, so if we have a square root or a fourth root or a sixth root, remember that c has to be greater than 0. So what I mean is, remember we can't take the square root of -4. Okay, remember that gives us an imaginary number, so we need that c value to be positive in order for this rule to work. Composite functions, the limit of f of g of x is f of the limit of g of x. You can use those rules, or you can just plug in like normal. So let's look here at this first one. The limit as x approaches 0 of the square root of x squared plus 4. First thing I want to think about is what's my n value? Okay, what's my degree? Or my index, sorry. So my index here, n, is 2. And that's even. So if we look back at our rule, c is 0, but c has to be greater than 0. So since our c value here is 0, and our n is odd, or n is even, this one actually we can't do. So I'm just going to do d and e. All right, for the next one, over here, same thing. I'm going to look and see what my index is 3, which is odd, so we can just plug it in like normal. So let's find the square root of 2 times 3 squared is 9, minus 10. And that's a cubed root. So 2 times 9 is 18. 18 minus 10 is 8. So the cube root of 8, which is just 2. So our limit is 2.